Here we are going to discuss about the Unit 4. Unit 4. In Unit 4, we have three topics: aldehydes, ketones, and carboxylic acids. Aldehydes, ketones, and carboxylic acids. And second one is amines. And third one is biomolecules. And these chapters, we are going to discuss in Unit 4. So first, we are going to start about the aldehydes and ketones. Aldehydes, ketones, and carboxylic acids. Aldehydes, ketones, and carboxylic acids. And carboxylic acids. Okay. So first we are going to discuss about the aldehydes and ketones. Then after completion of that, we go for carboxylic acids. So aldehydes, ketones are also called carbonyl compounds. Aldehydes and ketones are also called carbonyl compounds. Why? Because carbonyl compounds means C double bond O group. This group is called carbonyl group. C double bond O group is called carbonyl group, and the compounds with carbonyl aldehydes and ketones with carbonyl group are called carbonyl compounds. And all compounds with carbonyl group are not carbonyl compounds. For example, carboxylic acids, carboxylic acids, RC double bond OOH. Here also we have carboxylic group. And acid halides. In acid halides also we have carbonyl group. And also esters. In esters also we have carbonyl group. C double bond O R dash. And also amides. In amides also we have carbonyl group. C double bond O NH2. Amides. And anhydrates, acid anhydrates. Acid anhydrates also we have RC double bond O, OC double bond O R. All these compounds can have carbonyl group. All these compounds can have carbonyl group, but these are not treated as carbonyl compounds. So these are not carbonyl compounds. Why they are not carbonyl compounds means when whatever the group is attached with carbonyl group, along with that total group is considered as a functional group. Along with whatever the group is bonded with carbonyl group, the total can be considered as functional group. That is why they are not the carbonyl compounds. So only aldehydes and ketones are with carbonyl group are treated as carbonyl compounds. Aldehydes and ketones only treated as carbonyl compounds. And carbonyl compounds are two types: aldehydes, aldehydes and ketones. When we can say the compound is aldehyde, when we can say the compound is ketone means aldehyde if we taken in aldehydes both sides or at least one side of carbonyl group hydrogen is bonded. When both sides of the carbonyl group are at least one side of carbonyl group, when hydrogen atom is bonded, then they are called aldehydes. For examples here, C double bond OH. Here both sides of the carbonyl group hydrogen is bonded, or at least one side of carbonyl group when hydrogen is bonded. So this group is called aldehyde functional group. This is called aldehyde functional group. And aldehyde functional group is always present at one end of the carbon chain. That is why aldehyde functional group is also called as terminal. Terminal functional group. Aldehyde functional group is also called as terminal functional group. Now we go for ketones. In ketones, both sides of the carbonyl group is carbon atom is bonded. Carbon atoms are bonded. So here both sides of carbonyl group, both sides of carbonyl group, carbon atoms are bonded. Carbon atoms are bonded. Both sides of when both sides of the carbonyl group carbon atoms are bonded, then they are called as ketones. Here, this is the carbonyl group, and both sides of the carbonyl group carbon atoms are bonded. Because of that, they are treated as ketones. This is about the aldehydes and ketones. And ketones, based on their structure, divided into two types. Ketones are two types. What are they? Symmetrical or simple ketones and unsymmetrical or mixed ketones. First one is symmetrical. Symmetrical or simple. Symmetrical or simple ketones. Symmetrical or simple ketones means in which both sides of the carbonyl group, similar groups are bonded. Both sides. Both sides of carbonyl groups, similar groups are bonded. When similar groups are bonded, then they are called simple ketones or symmetrical ketones. And general formula, if we taken, general formula can be represented as, they are represented by using the general formula RC double bond OR, or we can say ARC double bond OAR. This is the general formula of ketones, symmetrical ketones. Symmetrical or simple ketones. For example, CH3 C double bond O CH3, acetone, or dimethyl ketone, acetone and dimethyl ketone are common names, and propanone is IUPAC name. Propanone is IUPAC name. So symmetrical, both sides of the carbonyl group. When both sides of the carbonyl group, similar groups are bonded, similar alkyl groups, similar allyl groups are bonded, then they are called symmetrical or simple ketones. Here we have both sides of the carbonyl group, phenyl groups are bonded. Diphenyl ketone, diphenyl ketone, diphenyl diphenyl ketone. Or we can say benzoyl benzene, benzoyl benzene also correct. And diphenyl methanone, this is IUPAC. Diphenyl methanone is IUPAC name. So in this way, ketones can be divided into two types. One is symmetrical or simple ketones, and second one is unsymmetrical, or mixed ketones. Unsymmetrical or mixed ketones means here both sides of the carbonyl group, same groups are not bonded. Similar groups, are not attached to both sides of keto group. Both sides of keto group, if different types of alkyl groups or allyl groups are bonded, means they are treated as unsymmetrical or mixed ketones. For example, see R C double bond O R dash representation, general molecular formula, general representation can be written as R C double bond O A R, Otherwise, we can also represent it by RC double bond O AR dash. So in this way, we can write the unsymmetrical or mixed ketones. And for example, here CH3, CH2, C double bond O, CH3, and different groups are bonded to both sides of carbonyl group. That's why they are unsymmetrical, or they are also called mixed ketones. This is about the classification, about the classification. And general formula, if we taken general formula of carbonyl compounds, general formula of carbonyl compounds, alkene general formula with oxygen. CnH2n is general formula of alkene, and along with alkene general formula, if oxygen is available, oxygen is attached, oxygen is taken, means that refers the general formula of carbonyl compounds, though both for both aldehydes and ketones. For both aldehydes and ketones, general formula CnH2nO. In this way, we can represent the general formula of aldehydes and ketones. Then we go for isomerism. Main isomerism exhibited by aldehydes and ketones is functional isomerism, FG. Functional isomerism, FI. Functional isomerism. So here in functional isomerism, aldehydes, comma, ketones, and aldehydes, ketones, comma, enols, and cyclic ethers are functional isomers. For a given molecular formula, we can write aldehyde, ketone, enol, and also cyclic ethers. We can represent the same given formula. For example, ketone. Ketone starts with minimum 3 carbon atoms. So ketone starts with for to represent the ketone, we require minimum 3 carbon atoms. That's why by taking 3 carbon atoms, if you go for the general formula C3H6O, according to general formula, 3 carbon atoms are taken, means CnH2nO. That's why C3H6O. So this is the, if this formula is given, means for this formula we can write aldehyde, we can write ketone, we can write enol and cyclic ether. And different compounds with same molecular formula treated as isomers. When they are differ by functional group, they are treated as functional isomers. That's why here we have CH3, CH2, C double bond OH, aldehyde, propanol, propanol, and also we can write CH3, C double bond O, and CH3. This is called propanone. Propanol is aldehyde, and propanone is ketone, and we can also write CH2 double bond CH and CH2OH. This is called allyl alcohol, common name, and PAC name if we taken prop CO, prop numbering 1, 2, 3, and prop 2 in 1 ol, prop 2 in 1 ol. So for these, all these molecular formula is same, C3H6O, but their properties are different. They are different compounds. And similarly, we can also write CH2, a cyclic ether, CH2O, and CH2O, cyclic ether. You know, cyclic ether is also possible. That is why all these are represented by similar formula, same molecular formula, but they are different compounds. Because of that, they are the isomers. They are treated as isomers, functional isomers, differ by functional group, functional isomers. And metamerism. Metamerism. This is shown by ketones. Shown by ketones and minimum carbon atoms. Metamerism show or to exhibit metamerism by ketones. Minimum carbon atoms. Minimum 5 carbon atoms are required. When with 5 carbon atoms, we can write two different forms. They are called metamers. In metamers, they are differ by molecular formula is same, and they are differ by the groups are attached with functional group. That is keto functional group. Keto functional group, when different groups attached with different types of groups, then they are treated as metamers. CH3, CH2, CH2, C double bond O, CH3, and CH3, CH2, C double bond O, CH2, CH3, and CH3, CH, and CH3, C double bond O, CH3. So we need to go for the configuration or go for the groups are attached with functional group, that is carbonyl group, and your carbonyl group is attached with N propyl methyl, N propyl N propyl ketone, and here carbonyl group, both sides of the carbonyl group, similar groups are bonded, that is diethyl, diethyl ketone, diethyl ketone. Here carbonyl group is attached with different groups. One is methyl isopropyl, isopropyl ketone, methyl isopropyl ketone. When different groups are bonded to both sides of the functional group with same molecular formula, all these compounds are represented by C5H10O, same molecular formula, but their different groups are attached with functional group. Functional group is bonded with different types of alkyl groups. Here alkyl group is N-propyl and methyl. Here alkyl group is diethyl. Both sides ethyl group is bonded with carbonyl group. Here isopropyl and methyl group. That is why they are treated as metamers, and this phenomenon is called metamerism. Metamerism. Metamers are the compounds, different compounds with same molecular formula, which are differ by nature of groups are attached with both sides of the functional group. They are called metamers. And metamerism can also exhibited by possible for other compounds. What are they? One is ethers. For ethers also metamerism is possible. Ethers and also esters and secondary amines. These also shows along with ketones. These also shows metamerism. Here we can also represent ketone, and can shows metamerism. In examination question is like this: which of the following cannot exhibit metamerism? Other than these cannot exhibit metamerism. Why? Because in these only we have uh, non-terminal functional group. Functional group is present in between middle of the chain, carbon chain, not at terminal position. Middle में कहाँ तो भी रहने वाला है, middle of the carbon chain. Because of that reason, such compounds can exhibit or participates in metamerism or shows metamerism. And we'll go with nomenclature. 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 First, we go for aldehydes. Aldehydes. In case of aldehydes, common names. Common names from common name of the carboxylic acid. Common name. Common name of carboxylic acid minus ic acid plus aldehyde is added. Plus aldehyde. By adding aldehyde, we can go for the common names of the aldehydes. Example, if we taken HC double bond OH, HC double bond OH, HC double bond OH is same carbon atoms, carboxylic acid with same carbon atom. So its common name is formic acid. Its common name is formic acid. That's why this becomes formaldehyde. Here we need to replace ic acid with aldehyde. That's why it becomes formaldehyde. And similarly, acetic acid, acetic acid, CH3 COOH, and this is acetic acid. And because of that, same aldehyde with same number of carbon atoms. This is called acetaldehyde. Acetaldehyde, acetic acid, acetaldehyde. Propionic acid, propionaldehyde. Butyric acid, butyraldehyde. Valeric acid, valeraldehyde. Valeric acid, carboxylic acid with 5 carbon atoms. That's why here we can write it as CH2, CH2, and double bond OH. This is called valeraldehyde. Valeraldehyde. And valeraldehyde can also written as N-valeraldehyde. Why? Because there is no branches. When carbon chain are in molecule without branches, we can add N. N indicates normal, no branches. And also similarly, we can write it as CH3 and CH2, C double bond OH. This is called isovaleraldehyde. Isovaleraldehyde. Iso, when starts with second carbon attached with methyl group means one methyl group means iso. And second carbon atom is attached with here from this any end. Second carbon atom is attached with two carbon atoms, two methyl groups. Then it is called neo neovaleraldehyde. This is about common names. In IUPAC, in IUPAC method, we can write alkane minus E plus al. By removal of E from alkane on addition of al, we can give the IUPAC name as alka non alkanol. They are treated as alkanols. Methane becomes methanol. Ethane becomes ethanol. So here HCHO. So one carbon atom, alkane with one carbon atom is methane. That's why this is methanol. Methanol. And acetic acid, acetaldehyde, ethanol. Ethanol. And three carbon atoms, aldehyde with three carbon atoms, propanol. Propanol. And here CH3, CH2, CH2, CHO. This is called butyraldehyde and N-butyraldehyde. Common name bracket me. Common name is written in bracket. And IUPAC name butanol. Butanol. IUPAC. Butanol. So this is about the nomenclature of aldehydes. And also we have CH2 double bond CH. Otherwise CH double bond CH and CHO. This is called, common name is cinnamaldehyde. Cinnamaldehyde. And IUPAC 1, 2, 3. 3-phenyl. 3-phenyl prop 2 in 1 all or 2 in all. 2 in all. There is a double bond between 2 and 3 carbon atoms. That is why 2 in. And all indicates aldehyde functional group. And aldehyde functional group always its priority is 1. Because of that, no need to mention its position. Its position. That is why directly we can write it as in all. So this is about the nomenclature of aldehydes. And if we go for ketones, In case of ketones, common method, common names. Common names are given by writing the uh, name of the alkyl groups are attached to the carbonyl group in alphabetical order. And finally, by adding ketone. And after name of alkyl groups are bonded to carbonyl group in alphabetical order, ketone is added. Ketone added as suffix. Ketone added as suffix. That is IUPAC. Sorry, common. Then IUPAC. In IUPAC, alkane, instead of E in alkane, by adding on, named as alkanones. They are named as alkanone. By removal of E from alkane, name of alkane, IUPAC name of alkane, by adding on, we can give the name as alkanone. Alkanone. For example, see CH3, C double bond O, CS3. So first we go for common name, and after the name of alkyl groups in alphabetical order. So both alkyl groups are same. That is why dimethyl, ketone, and propanone. In bracket, common name. Without bracket, IUPAC name. Propane, 3 carbon atoms. Alkane with 3 carbon atoms is propane. From propane, removal of E and addition of on. That is why propanone. Propanone is the IUPAC name. And similarly, CH3, CH2, C double bond O, CS3. And here we have both sides of carbonyl group. Both sides of carbonyl group. One side we have ethyl group and other side methyl group. So ethyl, methyl in alphabets, E, first letter E. That is why first we need to write the name of ethyl methyl ketone. Ethyl methyl ketone common name, and butanone is IUPAC name. Butanone is the IUPAC name. Butanone. So we can also use position also. So at second carbon atom we have keto group. That is why 2-butanone. And in case of aldehydes, always first carbon contains aldehyde functional group. Terminal functional group, for terminal functional group, no need to mention the position. But in case of non-terminal functional groups, we need to mention the position in their IUPAC name. And similarly, here we have CH3, CH2, CH2, C double bond O, CS3. And this one is methyl N-propyl ketone. Common name, methyl N-propyl. Methyl N-propyl ketone is common name. And if you go for IUPAC, 1, 2, 3, 4, 5, 2, 2 pentanone. Sometimes we can also represent it as pent 2-one. Both are correct. Both are correct. And similarly, it can also represent it like this. And here these two are not same, but another is also possible. So 1, 2, 3, 4, 5. So both can have 5 carbon atoms. But there is a difference in position of functional group. Here functional group is at second position, here functional group is at third position. This is called here diethyl ketone. Diethyl. Why diethyl ketone? To the functional group, both sides of the functional group we have ethyl groups. That is why diethyl ketone. and 3-pentanone, IUPAC. So this is about the nomenclature of carbonyl compounds. This is about the nomenclature of carbonyl compound. And here we have cyclohexanone, cyclohexanone, and here C double bond OH. This is called cyclopentane carbaldehyde. Cyclopentane. And this is not included. This carbon is not included. Pent, 5 carbon atoms only. That is why it is named as carbaldehyde. Cyclopentane carbaldehyde. Cyclopentane carbaldehyde. And here we have double bond OH, CH2, CH2, C double bond OH. And this is called 1, 2, 3, 4. Butane, 1, comma 4. Diol. Butane, 1, 4 diol. Butane indicates 4 carbon atoms. And 1 and 4 positions are with carbonyl group. That is why diol, aldehyde functional group. That is why diol. And here C double bond OH, CH2, CH, CHO, and CH2, C double bond OH. Here, when more than two carbonyl groups are aldehyde functional groups are present, then we need to give the numbering in this way. And we have propane 1, comma 2, comma 3 carbaldehyde. Carbaldehyde. They are also not included in parent chain. Parent chain only with 3 carbon atoms. That's why 3 carbon atoms are taken as propane and 1, 2, 3 carbaldehyde. Tricarbaldehyde. 1, 2, 3 tricarbaldehyde. 3 aldehyde functional groups are there. That is why tricarbaldehyde. Propane 1, 2, 3 tricarbaldehyde. And we'll go with preparation methods. Preparation methods of aldehydes and ketones. First one is from alcohols. From alcohols. From alcohols, we have two methods. One is by partial oxidation. And primary alcohols and secondary alcohols in presence of strong oxidizing agent, primary, secondary, tertiary also. In presence of strong oxidizing agent at vigorous conditions, they can produce carboxylic acids. For example, RCH2OH. This is your primary alcohol. When primary alcohol is oxidized in presence of K2Cr2O7, potassium dichromate in acidic media, or potassium permanganate KMnO4, potassium permanganate in acidic media, they are strong oxidizing agents. And by oxidation, first they can produce as the aldehydes or carbonyl compounds. Here aldehyde, we are getting aldehyde. And this aldehyde undergoes further oxidation and produces carboxylic acid. But we required only aldehydes or ketones. That is why we need to stop the further oxidation of whatever the carbonyl compound is produced. For that purpose, we need to use a weak oxidizing agent, or simply we can say mild oxidizing agents. Yeah, here take a note, in presence of strong oxidizing agents, alcohols converted into carboxylic acids. Carboxylic acids are the final products. So carboxylic acids, we need We need not to require the carboxylic acid. We require only aldehydes and ketones, that is carbonyl compounds. To stop the reaction at first step only, we need to take. Therefore, mild oxidizing agents are required. Mild oxidizing agents are required, which cannot further oxidizes, further oxidizes carbonyl compounds into into carboxylic acids. They cannot oxidize further into carboxylic acids. So what are the mild oxidizing agents are available means? Examples if we taken PCC, pyridinium chlorochromate, pyridinium chlorochromate. Pyridinium chlorochromate is nothing but it's a mixture of pyridine, that is C5H5N, pyridine plus CrO3 and plus HCl. This mixture is called pyridinium chlorochromate, and this mixture is exist in the form of mixture can exist in the form of C5H5NH plus CrO3Cl minus in the form of this complex. It can exist in the form of this complex. And pyridinium chlorochromate, this is also called as Corase reagent. This is also called Corase reagent. And another is also there, that is pyridinium dichromate, PDC, pyridinium dichromate. Generally here we can use CH2Cl2 as solvent, methylene chloride, solvent. Pyridinium dichromate. Pyridinium dichromate is C5H5NH taken dice and Cr2O7, and which is also in presence of methylene chloride. And also we have another one, Jones reagent. And here Jones reagent is two types. One is CrO3 in presence of acetone. Acetone water भी ले सकते. And other one is CrO3 in presence of sulfuric acid. And in presence of acetone and water can act as mild oxidizing agent. Mild oxidizing agent. And in presence of chromium oxide and sulfuric acid, this is strong oxidizing agent. So here we use this one. Mild oxidizing agent only here we are going to use. Why? Because we required aldehydes and ketones from alcohols. That is why we need to use mild oxidizing agents only. In presence of any one of these, alcohols can be converted into carbonyl compounds. If strong oxidizing agents are used means alcohols are converted into carboxylic. First they gives carbonyl compound and they undergoes further oxidation and produces corresponding carboxylic acids. And here we have RCH2OH, primary alcohol. And in presence of any one of these, PCC, CH2Cl2 or PDC, or we can take Corase reagent, that is CrO3 in presence of acetone and water, and produces RCHO. Primary alcohols can give aldehydes. And secondary alcohols can give ketones in this reaction. Secondary alcohols RCHOH and R. Here this is secondary carbon hydroxy group is present on secondary carbon, that is why secondary alcohol. And the secondary alcohol by oxidation, any one of these oxidizing agents, it can produce ketone is the product, ketone. And if it required aldehydes means we need to take primary alcohol, ketone is required means we go for secondary alcohol. And tertiary alcohol, if we taken in this reaction, tertiary alcohols, mild oxidizing agent, no oxidation. They cannot participate in oxidation. Mild oxidizing agent cannot oxidize the tertiary alcohols. Tertiary alcohol cannot oxidize. Tertiary alcohol. So here, for example, cyclohexanol, if we taken, here OH, and here cyclohexanol. Cyclohexanol is a secondary alcohol. So remove hydrogen from here and here, take the pi bond in between carbon and oxygen. So PCC and CH2Cl2. So we have double bond O. Cyclohexanone. Cyclohexanone. Cyclohexanol converted into cyclohexanol. So this is the way we can prepare carbonyl compounds from alcohols. And from alcohol, second method is catalytic dehydrogenation. Catalytic dehydrogenation. By catalytic dehydrogenation of alcohols. And here, primary alcohol can give aldehyde, secondary alcohol can give ketone, and tertiary alcohols cannot participate in the form of in the formation of carbonyl compounds. We'll see. Vapors of alcohols, for example, primary alcohol if we taken. Primary alcohol. And here, when passed over copper at 300 degree Kelvin centigrade temperature, 300 degree centigrade temperature, from here hydrogen, and we have RCHO plus H2, removal of hydrogen, dehydrogenation, removal of hydrogen, that is why dehydrogenation. If ethyl alcohol if we taken, ethyl alcohol in presence of copper at 300 degree centigrade temperature, and the product obtained is CHO plus H2. So acetaldehyde is the product. And similarly, secondary alcohols if we taken, RCH and OH and CSR. So here, from here hydrogen, and removal of hydrogen from carbon and oxygen atoms, and formation of the pi bond in between carbon and oxygen, then we are getting ketone. Ketone is the product. In this reaction, secondary alcohols can give ketones. Primary alcohols can give aldehydes, secondary alcohols can give ketones. And similarly, for example, CH3, CH, take in this form, bond and line method. यहाँ पे this is secondary butyl alcohol, and secondary butyl alcohol when treated with 300 degrees centigrade, passed over copper at 300 degrees centigrade. So from here hydrogen, this hydrogen and this hydrogen are removed, and formation of the double bond between carbon atom, pi bond between carbon and oxygen atom can takes, and we have a 2-butanone, and here butanone is the product. Butanone, ketone, butanone is the product. And similarly, when tertiary alcohols are taken in this reaction, in tertiary alcohols we don't have hydrogen on the carbon atom on which hydroxy group is bonded. Wherever the hydroxy is group bonded, that carbon atom cannot have hydrogen. If there is hydrogen, from here hydrogen, that hydrogen removal and formation of the pi bond between oxygen and carbon atoms. But here hydrogen is not available. Because of that, copper at 300 degrees centigrade, this can take hydrogen from here. And in this way, removal of water can take place. Participates in dehydration. First reaction is dehydrogenation, removal of hydrogen. Here the reaction is dehydration, removal of water. That is why dehydration plus H2O. Here dehydration. So tertiary alcohol, tertiary butyl, tertiary alcohols undergoes dehydration and ketones are the products. Sorry, alkenes are the products. Alkenes are the products. So in this case, ketones can give, tertiary alcohols can give alkenes. Alkenes are the products. So that is why secondary alcohols can give, primary alcohols can give aldehydes, secondary alcohols can give ketones, and tertiary alcohols can give here alkenes are the products. So this is from alcohols. Then we'll go with second one is from unsaturated hydrocarbons. Unsaturated hydrocarbons, that is alkenes and alkynes. Alkenes and alkynes. From alkenes and alkynes, how we are going to prepare uh, carbonyl compounds means first one is by ozonolysis, by reductive ozonolysis. Reductive ozonolysis. Reductive ozonolysis. In reductive ozonolysis, so carbonyl compounds are the products. So alkene or alkyne. Here I am taking alkene, general formula, and place ozone. And first it can use mole ozonide. It can use mole ozonide. It's a cyclic compound, 5-membered cyclic compound. It is called mole ozonide. And which undergoes hydrolysis in presence of water and zinc. In absence of zinc, oxidative ozonolysis, that is treated as oxidative ozonolysis. In presence of zinc, treated as reductive ozonolysis. So here, this oxygen is bonded with zinc, and this is dissociation of the bond and formation of the double bond in between RCH double bond O plus HC double bond OR. Wherever the keto group double bond is available in between carbon atoms, the double bond dissociates and each carbon atom is added with oxygen atom. So for example, if the compound is like this, and here CS3 double bond CH and CS3. By reductive ozonolysis, what are the products? Question is like this only, ZnH2O. So here, simply we need to do, what we need to do means, so we need to dissociate, break the bond, double bond, and each carbon atom is bonded with, attached with oxygen atom with double bond. And here, O, double bond CH and CS3. So in this way, we can get the carbonyl compounds, both the carbonyl compounds, ketones only. Yeah, here it is ketone, this is aldehyde. And aldehyde or ketone, that is decided by the structure of the alkene. Based on the structure of alkene, we can get similar or different types of carbonyl compounds. And if the carbonyl alkene given is like this, so ozonolysis and H2O in presence of zinc. So here also we need to break the carbon-carbon double bond, and here 1, 2, 3, 4, 5, and 6. Or 1, 2, 3, 4, 5, 6, 7. So we have uh, whatever the carbonyl compound we are getting, that carbonyl compound contains 7 carbon atoms. So 7, 1, 2, 3, 4, 5, 6, 7. And first carbon atom with double bond O. 1, 2, 3, 4, 5, 6, 7. And sixth carbon atom, double bond O. So this is the compound we are getting by ozonolysis. So what's the name? Name of the compound is 6-keto or oxo. 6-oxo hexanol. heptanol, heptanol, heptane, heptanol. And similarly, in this reaction, uh, alkynes also gives carbonyl compounds, but diones, they can give 1 2 diones in presence of ozone. First, they can produce same ozonide, but here carbon carbon contains triple bond, 3 bonds in between carbon atoms. In the formation of ozonide, only 2 bonds are participating, and other bond is left over as it is. And on hydrolysis, H2O in presence of zinc. So here, this electrons moves here, and this is with zinc. Then we have RC double bond O, C double bond O, R. This is called 1 comma 2 dione. 1 comma 2 dione are the products. So by ozonolysis of alkynes, general formula of alkyne is taken here. And here we have, for example, propine if we taken. Propine, propine in ozonolysis, O3, H2O and Zn. So here we have CH3C and CH, CH, and here also double bond O, here also double bond O. Its name is 2 keto or 2 oxo propanol. Aldehyde and keto functional group both are available. That's why 2-oxopropanol. 2-oxopropanol is the product. And then we'll go with by hydrolysis. By hydrolysis of alkynes. Alkenes on hydrolysis can produce alcohols. That's why we are not going to use alkenes. But from alkynes we can get the carbonyl compounds. From alkynes we can get the carbonyl compounds. For example, C. Triple bond CH and water. Generally, when this reagent is used, HgSO4 and H2SO4, when this reagent is used, addition of water can take place, and this reagent only present in case of alkynes only. When we are going to write the equations with alkyne by using this reagent, you need to take their addition of water is takes place. Addition of water is takes place. That is why after addition of water, one of the carbon atom is added with hydrogen, another carbon atom is added with hydroxy group. So we are getting unstable vinyl, vinyl alcohol. Vinyl alcohol is unstable, and by tautomerization, undergoes tautomerization. By tautomerization, it converted into stable carbonyl compound. CH3C double bond OH. Stable carbonyl compound is the product. And similarly, in this case, if unsymmetrical alkyne is used, when unsymmetrical alkyne is used, addition of water follows. MK rule, MK addition, Markovnikov addition. Markovnikov addition means negative part of the addendum is bonded with carbon atom with less number of hydrogen atoms. Here hydrogen atoms are not available. Unsaturated center. At unsaturated center, less number of hydrogen atoms. The carbon with less number of hydrogen atom is added with negative part. Negative part means in water we have H plus and OH minus. Negative part, which one is negative part means OH. OH is added with carbon atom with less number of hydrogens, and H is added with carbon atom with more number of hydrogen atom. That is called Markovnikov rule. Addition of water can take place Markovnikov rule. And we have CH3 here OH and double bond CH2. This is also unstable and undergoes tautomerization or tautomerism and produces ketone. Ketone is the product. CH3, C double bond O, CS3. Here ketone is the product. Undergoes Markovnikov of addition. And ketone is the products. So in this way, we can also go for the preparation of ketones and aldehydes by terminal. Yeah, here only acetylene can give aldehyde. Only acetylene. Here in this reaction, only acetylene gives aldehyde. Aldehyde. And other alkynes gives ketones. In this reaction, in this reaction, only this you need to remember. So maybe question can be expected. So only acetylene can give aldehydes, and other alkynes, if we take in, they can produce ketones. And another reaction is HBO. HBO reaction. HBO is nothing but hydroxyboration, hydroboration and oxidation. Hydroboration and oxidation. So here addition of water, addition of water on, addition of water opposite, opposite to MK rule. Here addition of water can take place opposite to MK rule. According to Markovnikov rule, hydroxy group is bonded with carbon atom with less number of hydrogen atoms. But here Markovnikov, opposite to Markovnikov rule means uh, hydroxy group, that is negative part, is added with carbon atom with more number of hydrogen atoms. That is why in this reaction, by this reaction we can prepare terminal alkynes. If we taken terminal alkynes can give, therefore terminal alkynes always gives aldehydes. In this reaction, terminal alkynes always gives aldehydes. For example, RC triple bond CH. Terminal alkyne. Terminal alkyne means triple bond, position of triple bond in between 1 and 2 carbon atoms. Then they are terminal alkyne. And here also addition of water. This will happen in presence of B2H6 THF. First step may in first step, and in second step hydrogen peroxide in presence of OH minus. Hydroboration first step, and oxidation. Hydrogen peroxide is oxidizing agent. Here finally what is happening means addition of water can takes. And this addition of water is cannot follows Markovnikov rule, and follows, that is called anti-Markovnikov rule, opposite to the Markovnikov rule. Hydroxy group is bonded with carbon atom with more number of hydrogen atoms. When less number of hydrogen atoms, Markovnikov rule. When more number of hydrogen atoms, anti-Markovnikov rule. Opposite to the Markovnikov rule. Then we have take these electrons here and these electrons here. Then go for the tautomerization, and we have CH2, C double bond OH. Aldehyde is the product. Aldehyde. Aldehyde is the product. So Markovnikov rule, anti-Markovnikov rule. So based on the requirement of the product, if aldehyde is required from terminal alkynes, means you go for HBO reaction. And Markovnikov product, that is ketones, are required from terminal alkynes, means go for simple mercuric sulfate and sulfuric acid in presence of mercuric sulfate, and hydrolysis in presence of mercuric sulfate and sulfuric acid. So that is about the uh, from alkynes and alkenes. And also we have alkynes, we have another alkenes, we have another method, that is Walker process. In Walker process from alkynes, see Walker. In Walker process, generally CH2 double bond CH2 plus H2O in presence of palladium chloride and copper chloride, cupric chloride. Cupric chloride, or we can also use instead of cupric chloride, cadmium chloride also can be used. Cadmium chloride can also used. So here the product is no, here of O2, and the product is CH3 CHO along with HCl plus palladium. 2 moles of HCl plus palladium. And also when aldehyde. So here CH3 CH double bond CH2 if we taken, and oxygen plus palladium chloride and cuprous chloride or cadmium chloride, and the product is CH3 C double bond O CH3 plus palladium plus HCl. So in this way we can get the products. Aldehydes or ketones can be prepared. So here ethylene can give aldehyde and remaining alkenes can give ketones by this reaction. So this is Walker process. Then next one is from carboxylic acid, dry distillation. Dry distillation of carboxylic acids or their calcium salts. Carboxylic acids are their calcium salts. When carboxylic acids are their calcium salts are on heating, can give can give different types of carbonyl compounds. Here, formic acid and plus formic acid. Formic acid plus formic acid. And on heating, generally manganese oxide, manganese dioxide, manganese oxide. Both can be used. So here, formic acid if we taken, and it can give formaldehyde. HC double bond OH plus carbon dioxide plus water. Carbon dioxide plus water. If we take this one is in this way. So here, from here, from here water. This is removed as water. And this has carbon dioxide. Now this one is added with this carbon. So what we have? Formaldehyde. And this one is carbon dioxide and water. So in this way, we can get the formaldehyde. Formic acid gives formaldehyde. Formaldehyde. Formic acid gives formaldehyde. And any other carboxylic acid with formic acid. Any other carboxylic acid with formic acid. So here also on eating in presence of manganese dioxide or manganese oxide, manganese dioxide. So here from here water and from here carbon dioxide. This alkyl group is added with this one. So you are getting RC double bond OH plus carbon dioxide plus water. So aldehyde. So here mixture of carboxylic acid other than formic acid and formic acid. Carboxylic acid other than formic acid and with formic acid. When both the mixture of both these are heated in presence of manganese dioxide can give aldehyde. And similarly, only carboxylic acid if it is R C double bond O O H, H O C double bond O R. Same carboxylic acids. And here also manganese dioxide and E. So here also we have hmm, this one is carbon dioxide, and from here water, and this alkyl group is bonded with this one. So we have ketone plus carbon dioxide plus water. So ketone is the product. That's why formic acid, if we taken, we can formaldehyde. Mixture of carboxylic acid other than formic acid and formic acid, aldehyde. Other than formic acid can give ketones. So based on the requirement, we need to take the required carboxylic acids. For example, see, if we go for acetaldehyde plus formaldehyde, sorry, acetic acid plus formic acid on heating, dry distillation. So what we have? Acetic acid plus formic acid. Acetic acid plus formic acid. From here water. From here water and carbon dioxide. Methyl group is here. So acetaldehyde is the product. So whatever the carboxylic acid we are going to take along with formic acid, that aldehyde we can get. Acetic acid gives acetaldehyde. Or the or if only acetic acid is taken plus HO, C double bond OH, C double bond O CS3, and on heating. So from here carbon dioxide, from here water. So we have CH3 C double bond O CS3 plus H2O plus carbon dioxide. So in this way, we can get the carbonyl compounds from carboxylic acid by dry distillation. Not only carboxylic acid, their calcium salts also. For example, HC double bond OO, HC double bond OO, and here Ca plus minus plus 2. Or in this can also represented as HCOO taken as Ca. So for our convenience, I am written like this. So on heating by loss of calcium carbonate, from here calcium carbonate. So this hydrogen is just shifted to this carbon. That's why what we have HC double bond OH plus carbonate. Calcium carbonate. This is called here calcium formate. When calcium formate is heated on strong heating, so can use formaldehyde. And similarly, CH3C double bond OO and CS3C double bond OO and Ca. And similarly Ca2, Ca plus 2 and C double bond OH and O, C double bond OH and C double bond OH. Mixture of calcium acetate and calcium formate. You can get formaldehyde, acetaldehyde. Acetaldehyde plus 2 moles of calcium carbonate. 2 moles of acetaldehyde. How means see here from CO like this. A methyl group. This methyl group is shifted on this carbon. And here also from in this way. And this methyl group is shifted on this carbon. That is why we have the mixture of acetaldehyde and also calcium carbonate. Acetaldehyde and calcium carbonate. And similarly, any one of the carboxylic acid if you take. For example, I am taking its general formula as O, and here RC double bond O and Ca plus 2 minus. And on heating. So here we have like this. removal of calcium carbonate again. So this alkyl group is shifted to carbonyl carbonate, produces ketone. Here ketone is the product along with calcium carbonate. So in this way, we can go for the preparation of carbonyl compounds by different methods. And next one is from Grignard reagents. From Grignard reagents. Hmm. From Grignard reagents. GR. Grignard reagent. Grignard reagents when added to esters. Grignard reagent GR plus ester followed by hydrolysis. Followed by hydrolysis can give carbonyl compounds. Followed by hydrolysis can give carbonyl compounds. So here RMGX plus ester of formic acid. Here methyl formate I am using. Methyl formate and Grignard reagent added. So here partial positive, partial negative. And here partial negative, partial positive. Negative, positive say, and positive is added with negative, attached with negative. So in this way, we can get a added product and HC OMGX MGX, okay. And here OCH3. So which on hydrolysis? On hydrolysis. And both are participates in hydrolysis and can give gemdiol. 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 Gemdiol means two hydroxy groups on same carbon. This is called gem or geminol. Gemdiol. Geminol diol भी बोलते हैं. Gemdiol is also correct. Gemdiol. And gemdiol by loss of water. By loss of water can convert it into carbonyl compound. Aldehyde. Here we are getting aldehyde. For preparation of aldehyde, along with Grignard reagent, we need to take ester of formic acid. Ester of formic acid can give aldehyde. And ester of other carboxylic acid other than formic acid can give ketone in this reaction. I'll by taking example, by taking directly example, I'll give the equation for other than. So here, for example, ethyl magnesium bromide. Ethyl magnesium bromide is Grignard reagent, and when treated CH3 C double bond O CH C double bond O OCH3. So here methyl acetate. Here also same thing. Magnesium bromide is added with oxygen, and ethyl group is added with carbon. So we have a adduct. Added product is called adduct. So CH3 CH2 ethyl group. No. So as it is, we can CH3 C OMG OMGBR both adductible. Adduct. This is called adduct. Why? Because added one. Added product. By addition reaction between these two, we are getting this one, that is why adduct. And H3O plus hydrolysis. And both can participate in hydrolysis. And we have CS3, C, here OH and OH and CH2, CS3. And which is unstable because of gemdiol. And the product is CH3, C double bond O, CH2, CS3. Butanone is the product. And it is possible to prepare both aldehydes and ketones by this reaction, by this method. And whatever the required carbonyl compound, that is depends upon the reactants we are taken in this reaction. Which reactants we are using, that can decide the products are produced during the reaction. And next one is from nitriles. B. Same Grignard reagent from nitriles. From nitriles. Nitriles are nothing but cyanides. RN, RCN. Or hydrogen cyanide also we can use here for preparation of carbonyl compounds. So here also same thing. RMgX plus HCN triple bond N. So can use here partial positive, partial negative, partial negative, partial positive, and negative is bonded with positive site and positive is bonded with negative site. And here we have RCH double bond N MgX. And on hydrolysis can give carbonyl compound. So hydrolysis. In hydrolysis, H2O. Both the hydrogen atoms are bonded with nitrogen and this oxygen is bonded with carbon. So what we have? RCHO plus NH2MgX. So aldehyde. To get aldehyde, we need to take hydrogen cyanide. If you use hydrogen cyanide, that can give aldehyde is the product. For example, in this reaction, phenyl magnesium bromide if we taken, MgBr, phenyl magnesium bromide. When phenyl magnesium bromide is treated with HCN, and first we can get the same adduct and MgBr. So what we have, you can get, and here CH double bond N MgBr. And on hydrolysis, so here also same thing, acidic hydrolysis. Here also same thing, and benzaldehyde is the product. Along with that, NH2 MgBr, NH2 MgBr. So in this way, we can get the aldehydes. And similarly, when any other cyanide MgX other than hydrogen cyanide means any alkyl cyanide, if we take here, what happens? Same partial positive, partial negative. Here partial negative, partial positive. So negative is attached with positive and positive is attached with negative. So what we have? R C and here R dash double bond N MgX. And which on hydrolysis? Same manner undergoes hydrolysis and oxygen is bonded with carbon with double bonds. That's why R double bond O R, C double bond O R dash, and plus NH2 MgX. So possible to prepare ketones also. So this is common methods for aldehydes and ketones. Preparation of aldehydes and ketones. These are the common methods for preparation of aldehydes and ketones. Okay, students, remaining we'll discuss about in next class, tomorrow's class. Thank you.
Visit shaheengroup.org